In this video, I want to have a look at trigonometry with small angles. So to do that, we're going to jump over into GeoGebra and have a look at a couple of different functions. So the first trigonometric functions I want to have a look at are sin x and tan x. And I want to have a look at what happens when our angle gets close to 0. So I'm also going to add in the function, just a straight line, y equals x, which goes along here, that green line there. To have a look at what's happening here. So they're three very different functions, but what's interesting is when we get close to 0, and if we zoom in on there we can see it even more clearly, is that they pretty much become the same function. They have the same value when our x or our angle is getting close to 0. If we keep zooming in even further, you can hardly even tell the difference. So when sin x and when tan x approach 0, they approach this line just f of x equals x. So what that means is if we were to divide sin x by x, we'd end up with 1, because you're pretty much dividing something by itself. If you divide tan x by x when our x is close to 0, then we pretty much end up with 1 as well, because they look very close to being the same thing. So the way we write that looks like this. So what we have is the limit as x approaches 0 of sin x over x is going to give us 1, because as x approaches 0, sin x and x approximate each other. They pretty much become the same thing. And in the same way, the limit as x approaches 0 of tan x over x is equal to 1 as well. So we can use these, and the main one we're going to use is this one, the sin x over x equals 1, but we can use these to solve limit problems. Let's have a look at evaluating a couple of limits. So our first question is going to ask us to evaluate the limit as x approaches 0 of sin x over 3x. Now we know that sin x over x is equal to 1, or the limit of that as x approaches 0 is 1. So we're just going to pull this 3 out. So this is going to be the limit as x approaches 0 of a third times sin x over x. And we can pull that 1/3 out the front of the limit as well. So we can have a third times the limit as x approaches 0 of sin x over x. And we know that this whole part is equal to 1. So we would just end up with a third. So our second example is going to ask us to evaluate the limit as x approaches 0 of tan of 4x over 5x. So to do this, we know that tan of 4x over 4x, so having that same constant in front of the x, or coefficient of x, that would be equal to 1. So if we put a 4 in here and a 4 down here as well, that limit's still going to hold. But we've got a 5, not a 4, so we're going to have to manipulate this. So we're going to still have the limit as x approaches 0 of tan 4x over 4x. But what that means is we've had to pull that 5 out the front as a constant. And because we've divided by 4, we need to multiply by 4. So this is just compensating for the fact that we've put that 4 down there instead of the 5. So now we can pull that 4/5 out the front. So 4 over 5 times the limit as x approaches 0 of tan of 4x over 4x. So we know that this whole section is 1. So we just end up with 4 over 5. Those are a few examples of evaluating limits of our trig functions as our angles get small.